I'll discuss only the concept, calculation you do later on. So we have a rod here. We have a rod. So there's the end A, there's the end B. One end is kept at 0 and the other is brought in contact with a steam bath of 100 degrees Celsius. Let it be. The surface of the rod is isolated so that it can flow only lengthwise along. The cross-sectional area is given, length given, thermal conductivity given, is density given, specific heat is given. Consider a short cylindrical element of rod, not rod, rod 1 centimeter in length. If temperature gradient at the polar end of this element is, so I think it's asking us to take two elements. I think this question is there in SC Verma also. Somebody posted me in WhatsApp group. Today only I saw it, I replied. What is the temperature gradient at the other end of element? He's asking what is the temperature gradient. So shall we say same? And average temperature of the element is rising 0.250 degrees Celsius per second. Definitely I can see it's a good question, no? where is testing your basics. So there are two quantities. Something is telling temperature gradient at polar end. Average temperature of element is rising at rate of change of temperature. That one, and is asking temperature gradient at polar end and outer end. Okay, let's do one thing. So let's have this one. HA, here HB. HA is equal to, we usually write temperature gradient dAT dTA by dx. Then what is HB? dt by dx, temperature gradient. And now what will happen to the rod? So if you look at the HB, what thermal power, initially I think a rod is initially at 0 throughout. One end is kept brought in contact with a steam bath at the surface of the rod is so that heat can flow only lengthwise rod. So as the heat flows, so what happens, the rod is not fully lagged here. It's not properly lagged. It is not at steady state. We are discussing this problem not at steady state. Am I right? This is, so now what will happen is like the rod starts absorbing heat. Different. So here if you see the difference, H is equal to HA minus HB, I'll write it. Now what is HA? MS dt by T. So this will be dt by dt KAMS. We have to interpret these terms. What is the meaning of that? This is what that average is given. And what is dTA by dx that is given is asking this particular quantity. Do we know thermal conductivity, everything? But okay, sir, what actually meaning of this? What is the meaning of this? Is it fully lagged? Lagged means, what do you mean by that? Is it at steady state? The rod is not at steady state. Usually we discuss the problems after reaching the steady state. We used to solve here. So here what will happen? The heat will start flowing. As the heat start flow, the different elements will start absorbing heat. And due to that, what happen, the temperature starts rising. So how do the heat? I think it should flow from here. Huh? Little bit some correction is there in diagram. It will flow from higher to lower one. I think I'll make some. It should be like this, huh? TB that one. So it's not it's not a fully lagged here. Like this, what happen as the heat flows and the different elements start absorbing heat, then what will happen once, so like when it is lagged here, no longer further absorption will occur, only transfer of heat will occur. When only transfer of heat occurs, then what will happen to the temperature gradient, dt by dx. When h constant, k constant, then temperature gradient will become uniform. Agree this? So this is not at steady state. The rod is not at steady state. We can't integrate any other thing. Come for this. Okay, now I'm testing your basics again.